Hi everyone, it's Mrs. Griffin with the Unit 3 Lesson 14 video. We're going to be describing rigid motions. So when you're doing that, you're either going to name or construct every point or line that you use to refer to, and we'll be describing what has happened between an image and its pre-image. So for a translation, you do need to name the vector if it's on a regular plane or a shift pattern if it's on the coordinate plane. For the rotation, you do need the center of rotation and the angle of rotation, which will either be the name of it if it's on the regular plane or the degrees if it's something on a coordinate plane. And for the reflections, which is either a line or a point of reflection, you'll need to name that, either the name of it or the equation or coordinates, depending on whether it's on the regular plane or the coordinate plane. In order to be able to do any of these, though, we first need to know how to reflect a line, shape over a line. So with our compasses, to reflect this quadrilateral over BC, since BC is what we're reflecting over, it's going to remain fixed. We're not going to move B or C. So what we're going to do is we're going to measure how far away each of these points, the other two, are from B and C. So I'm going to measure from B to A, and I'm going to take that distance from B to A, and I'm going to swing an arc that says A is this far away from B, and then you can either swing it all the way around or just spin it to the other side of the line and reflect it over, and we'll say A is going to be somewhere on this arc. So it can be the entire arc or just the two pieces. We're going to do the same thing to figure out how far away D is. So we're going to measure with our compass the distance from B to D and swing an arc to the other side of the line. Now C is going to remain fixed, so I don't need to measure how far away it is from B. Instead, since C is the other point that's going to remain fixed, I'm going to measure from C to A and do the same thing I did with B. I'm going to make an arc, and A is here. So if I swing it around, this point where those two arcs meet will be A prime, and it's reflected over BC. Then I'm going to do the same thing to measure from from C to D. I'm going to take the compass and measure that distance, and then I'm going to swing the arc either up or down, it doesn't matter, as long as it crosses the other one. And then that point of intersection will be D prime, which has been reflected over line BC as well. And then when I connect those two together with B and C, we'll have our shape reflected over line BC. Same thing for this triangle. We're going to reflect over EG, so both E and G will remain fixed, and all we have to do is measure point F and reflect point F over. So we're going to measure from E to F, and swing it around. And then we're going to flip it over and measure from G to F as well. And then swing that around, and then the point of intersection will be F prime, which has now been reflected over EG. And then you can connect them together to get your new triangle. Now doing that's a huge part of what we're going to possibly be doing for the rest of the lesson. So on to number 3. Now for these, what we have to do is, since we're on the coordinate plane, we have a little bit more, it's a little simpler. We're going to be able to count boxes. So we have to figure out for part A how to map ABC onto DEF. There's going to be dozens of correct answers to this. So what I would first probably do is try to figure out if I could translate or reflect to get ABC closer to DEF. And so personally, I would translate it 2 units to the right, and then I would translate it 1, 2, 3 units up so that it would be closer to the original triangle, and then I would flip it over the y-axis. So that is one way that we could do this. You could first translate it right 3, 2, up 3, then reflect over the y-axis. And lots of other ones are going to be correct. For B, adjust this, the letters are in the wrong order. First thing I would probably do to try to get this closer to that is I would translate it to get a corner at least together. So I would take this shape, EFGH, and I would go 1, 2, 3, 4, 5 left and up to 3. And then I would reflect it over y equals 2, which is that horizontal line right here where the letter T is. And that would end up in the right place. So if you came up with different answers, that doesn't make yours wrong, just a lot of different ways to do these ones. Now, for the ones on the plane, there's going to be more than one correct way often, but I'm going to show you the simplest way for each. So for number 4, in order for triangle ABC to map to AB triple prime C, you have to do possibly many different things, but the easiest thing I see that we could do is just simply reflect it. And just put it right over line AC because that line is already there. Seems the simplest to me. So don't think that the number of primes means there has to be 3 steps. Okay, for number 5, there's a few different ways you could do this. To me, I see that it's a reflection. I just don't have the line of reflection in the picture this time. So I'm going to construct it. I'm going to go more than halfway between C and C prime, and I'm going to construct that line of reflection. So remember, when you're doing that, it's a perpendicular bisector between a point and its image. And then we just need to put that line in there. So putting that line in will give us a line of reflection to go through. If you're not sure if it's a direct reflection, you can always do a second one to see if you get the same line. And if you do, then it is going to be definitely a line reflection. And then we're going to label that line L. And then we're going to just describe what's happened here. So for this one, this is a reflection. So reflect triangle ABC over line L. And you should use a cursive L. I just don't have that font here. Okay, now for number 6, it's going to be a little bit more complicated. We do have what appears to be a rotation, not a reflection. So we definitely can't just straight reflect it, because if we did, C would actually land here instead of where A is, and that's not going to work. So if it's a rotation, then we can construct a center of rotation. So more than halfway, C should land on A. It should correspond to A. So if we're rotating, that would happen. More than halfway between A and C, and then do the same thing from the other end. And we connect those to make one of our lines. And then another pair of points that would correspond were B and D. So B would land on D. And more than halfway between those, we're going to construct that line. And then when we draw that one in there, we will have our center of rotation. If you happen to note, it is the midpoint of BD. And so we're rotating the triangle ABD around point M by angle. And then if you look, we would name it A, M is the center, and it would correspond to C, or B would go to M and then to D. And if you happen to note this time, that happens to be 180 degrees. Most of the time you wouldn't get a number on the regular plane. Okay, looking at 7, this is also another rotation, so we're going to construct a center of rotation. So 2 perpendicular bisectors. So we're going to go from A to D and then F to C. And if you notice, since they're all on the same line, the perpendicular bisector between those two should be the exact same line and should get you the exact same midpoint. Okay, because if I go more than halfway between A and D and I construct this line, it's going to get me a midpoint between AD. And then if I were to do the same thing between F and C, we're actually going to get the exact same point. So if you're not sure, because you'll get the exact same line even, you can always go between B and E. Okay, so more than halfway between a different pair of letters if you're finding that things aren't making sense or confusing you. But the reality is that the midpoint between F and C is going to be our center of rotation. Notice that that line AD is the perpendicular bisector. So anytime things are perfectly symmetrical like that, that's going to happen. So this point here is going to be our center of rotation. Name it with whatever letter you would like. I choose P. And so we're rotating triangle ABC around point P by angle, and then you're going to pick a letter, A, or any letter from the original, then the center of rotation P, and then where A would land, which is D. You could also have done B would go through P and land on E, or C would go through P and land on F. And again, this does also happen to be 180, although that's not common. Now for number 8, we have some unnamed triangles. So I'm going to start by labeling some of these corners, A, B, and C, just to have some reference points here. Now if you notice, when we are looking at this, A goes from the smallest angle to the one that's marked off. So over here, this would be corresponding to A, and then over here would be corresponding to B. So I'm not sure how many primes that would be. I'm going to go with 3 just because it seems like there's going to be a lot going on here. And then this one would have to be C. You can always add primes as you go if you're not sure how many. So that means that on the original, A, B to C, I'm labeling that in a clockwise direction. If I look at the final one, A, B to C, I'm labeling that in a counterclockwise direction. That means the orientation changed. So that means there has to be a line reflection going on here. So I'm going to need to construct that line, that reflection. So I'm going to start with my ABC, and I'm going to reflect it over, I'll choose AB. It doesn't matter which side, but I like to pick the largest one to reflect over. So that means A and B are going to remain fixed, and I'm going to reflect point C over AB. So I'm measuring from A to C, and I'm going to swing that arc, and then I'll do the same thing from B to C. I'll measure that. And then swing that arc, and then figure out where point C would now land, making this C prime. And I'll put the triangle in. So now I have A, B, and C prime. If you would like to change this to A prime and B prime, you may. Instead of leaving them as A, B, it's fine either way. Now, if you notice, what would happen is that this mark would move here. This angle would be here, and our double marking is still in the middle. That means I have to figure out how to get from this triangle, the A prime, B prime, C prime, to the final one. In order to do that, I clearly have to rotate the triangle. So I'm going to construct the center of rotation. I am going to pick a point. I'll choose A and A prime and A triple prime, and I'm going to make a perpendicular bisector between them. And draw that line in. Then I'll choose another pair like C triple prime and C prime here, and I'll do a perpendicular bisector between them. And draw that line in. And where the two perpendicular bisectors meet will be my center of rotation. I'll call it point P. And then finally, to describe it, we went a reflection over A prime, B prime, or AB if you left it that way. And then a rotation around P by angle A prime, P, A triple prime, or however you named them. All right, I'll see you in class.